Hello, everybody. Okay, so I'm just recording this lesson for any of you that understand it. This one's also pretty easy as well. But this hopefully is something that you learned in your Algebra 1 class. But if not, it's okay. That's the purpose of this video. Okay, so average rate of change. So recall the average rate of change is basically the same thing as the slope. So you might remember from Algebra 1. So slope is you take rise over run, which is y2 minus y1 in the numerator over x2 minus x1 in the denominator. So here's an example. Okay, so let's say Ezra's on a hike. The table below, this table here, shows some values that represent his elevation when he's hiking after so many hours. So find the average rate of change for each prompt. So all the prompts are here. So that's what I'm going to show you how to do. Okay. So you want to find the average rate of change from 1 to 6 hours. Okay. So what we have to do is we have to identify 2 points. So what we have here is after 1 hour, he is at an elevation of 200 feet on the hike. The other one, so after 6 hours, he's going to be at an elevation of 500 feet. Okay. So the equation that you'll use to determine his average rate of change will be this one. So y2 minus y1 over x2 minus x1. Okay, so all you do is just plug in your values. Basically, you're just solving for slope. This is y2. Okay, so that's 500. This is y1, that's your first value, so 200. X2 is this value, 6. X1 is going to be this value, so just 1. Okay, so all we're doing is we just solve, we want to simplify this. So 500 minus 200 is going to be 300. 6 minus 1 is 5. 300 divided by 5 is going to equal 60. So in context, this is feet per hour. Y is on top, X is on the bottom. So 60 feet per hour. Okay, so that means at every hour he's climbing up the mountain at an average of 60 feet per hour. And that's your answer. That's what that is. Okay. Okay. Second problem. Okay, so it says you want to find his average rate of change from 2 to 4 hours. So from 2 to 4 hours, again, you're looking at your your value. So after 2 hours, he has traveled he has climbed an elevation of 1,000 feet. Okay, 4 hours. So after 4 hours, he has gained an elevation, or actually decreased in elevation, to 500 feet. Okay, so same idea. Use y2 minus y1 over x2 minus x1. y2 is going to be this value. This is 500. y1 is going to be this value here. So it's going to be 1,000. x2 is going to be this value. So this is 4. X1 is going to be this value. So this is 2. So all we have to do is just simplify this. So if we simplify this down, 500 minus 1,000 is negative 500. 4 divided by 2 is 2. Okay, negative 500 divided by 2 is negative 250 feet per hour. Now, it just so happens these numbers are coming out nice. Doesn't mean these numbers are going to come out nice all the time. But what this means is that from 2 hours to 4 hours, the average rate of change per hour, Ezra is decreasing 250 feet per hour. That's what that is. Okay. Now let's say we want to find the average rate of change from 0 to 7 hours. Okay. 0 to 7 hours. Let's go and define our points. So 0 at 0 hours, he's at an elevation of 30 feet. So that indicates when he started the hike. We have another value here. We can find out after 7 hours, then he is at another elevation of 30 feet. So perhaps what that might mean is maybe after 7 hours, Ezra has finished that hike. Maybe he hiked Olomana or something, and hopefully did all 3 peaks. Anyway, what you would do to calculate this is, so same idea. This is y2. So y2 is right here. That's 30. y1 is going to be this. So that's going to be right there, 30. x2 is this value, so 7. x1 is that value, so that's going to be 0. Okay, so 30 minus 30 is going to be 0. 7 minus 0 is going to be 7. And 0 divided by 7 is 0 feet per hour. So that means his elevation, his average rate of change per hour, in this case would be 0 feet per hour. Okay. All right. So the next part. So this is based on a given interval. Is Ezra's average rate of change positive, negative, or equal to 0? And what you want to do is you want to place a check mark where each of it applies. Okay. So let's try to look at each of these. So it says from 1 to 6 hours, right? I'll put this in a nice little color. So from 1 to 6 hours, right? So if you look at this, the rate here, he's going, his elevation is increasing per hour. Since his elevation is increasing per hour, his rate of change is going to be positive. He is going up the mountain. Okay? Now this other example, so from 2 to 4 hours, if you look at this here, you look at that right there, the negative in front, that means that his elevation is decreasing at a certain rate per hour. This means from 2 to 4 hours, his rate is going to be negative. Okay. And the last one, so this one, so from 0 to 7 hours. Okay, so from 0 to 7 hours, what we're doing is, if you look at this, his rate of change is not increasing or decreasing. It's 0 feet per hour. So in this case, this would be equal to 0. So yeah, yeah, that's pretty much it. Okay, so if you guys are wondering about this rate of change, so you might have seen this in your Algebra 1 class. Rate of change is basically a change in y divided by change in x, and that's basically the same thing as finding the slope. I want to show you some different ways this is also shown. So you might have seen like change in y and change of x. It's also shown with like a little triangle thing. I wonder if I can find it. Well, it says like okay, just remember triangle is delta y. I can't find it. Just use your imagination. Triangle x. So yeah, okay. Oh, there it is. Okay, so that's what it is. So some of you may have seen it in your science classes maybe, but it looks like this. So change in y over change in x. That's basically the same thing as rate of change. Another way that some of you may have also seen it presented, so average rate of change, you might also see a formula that looks like this. So it would be like f of b minus f of a over b minus a. That might be another way you might see that. They all mean the same thing, but basically this means their output. This is the output of b, and this is the output of a. So basically it's the same thing as the slope formula. But yeah, that's just one other thing I want to show you if you try to look up other videos. But anyway, that's it for this lesson. Hopefully this helps. Okay, bye.